This is the dashboard that we created in collaboration with the Zanmi Kafe project and Sewanee DataLab. Their work offsets carbon emissions by planting trees on Haitian farms, which improves economic stability for the farmers. Our client needed a way to pay farmers and to efficiently calculate carbon sequestration using a vast amount of raw data. To solve this issue, we developed this interactive dashboard that displays and analyzes the data.
This is the main panel of our dashboard. It allows the user to compare carbon sequestered, carbon payments, and trees planted across multiple years. You can pick between the years 2019, 2021, or both. Then you can choose a household. You can look at individual farm data from the 51 households or the totals across all farms. Here you have radio buttons that produce 3 different graphs. These correlate with each of the value boxes shown underneath. The value boxes give totals for carbon sequestered in tons, how much is paid to the farmers, and the amount of trees in each farm. The 3 graphs show these totals broken down by tree species and compare carbon sequestration on the same farm or overall. Next, we have the Regressions tab. For each individual tree, we log transformed tree height and diameter and grouped each tree by species to plot them as regressions. In theory, tree height and diameter should be correlated with each other, but it may not always be the case due to errors and fraud. This tab allows the user to look at the raw data points and visualize discrepancies between years and households.
This is the tab that compares allometric equations used in our calculations. Our allometric equations calculate the amount of carbon sequestered. The equations function in slightly different ways, leading to drastically different results. These equations show immense differences in the amount of carbon absorbed. For example, when you look at mango in the year 2019, mango sequesters as high as 36 and low as 3 tons of carbon, even though it is known that mango trees are super absorbers of carbon. By comparing the allometric equations based on species and year, our client determined which calculations most accurately measure the carbon absorption of each tree species, and we have used these equations in our main panel to show our findings.
We hope that this dashboard can continue to remain useful by receiving new data from future years, as well as serve as a model for other small-scale carbon markets. Our next steps include adapting our project to allow for faster growth and more in-depth analysis of the datasets. We are excited to watch the Zanmi Kafe project grow and change in years to come. Thanks for watching.